All right, so I did type up the outline and we're looking at up to 13 problems. The FR on this outline means free response. And then the rest are multiple choice, or what's that other one where it's not just one choice, but several choices?
It's
Multiple.
like little tick boxes where you pick all correct options, but don't pick any ones that are wrong.
Yeah. So is there a name for that? That's like multiple
I have
something.
no idea.
So there's multiple choice, and then there's this other one where you get to choose from several things. And FR free responses. The free responses are like 4 points or something, 3 or 4 points, and then the rest are 3 points, maybe. I don't quite remember. And then the true false are 1 point each. The WebAssign portion has 16 problems, and then they're coming from a variety of sections from chapter 14 and chapter 15. The last two problems I think are 4 points. The rest are 3 points. The last two problems are multiple integrals in cylindrical coordinates and spherical coordinates. Okay, so that's the setup. And let's see. Are any of these things standing out as anything that you want to take a look at from maybe number 5 through 11 here?
So I remember having trouble with the local Extrema questions. So 7, 8, and
Okay.
9 and 10 gave me a bit of trouble.
All right.
Rest was I either was comfortable that my answer was correct, like the free responses, or at least close enough to get enough credit to, to get maybe 3 points out of 4 at least. But those stumped me a little bit because sometimes I have to write it out and I can't visualize it as well. But I wasn't sure if you would mind if we use scratch paper. So I'm just sitting there trying to visualize it in my head and just going, oh boy. But those were the ones that gave me a little bit of trouble. And yeah.
All right.
There were a couple of trick questions that you put in there. One of the true false ones. I was kicking myself when I missed it.
So those true false ones, I didn't, those ones I copied directly from the textbook.
Well, then the textbook is a jerk.
Yeah. Yeah. So let me get things set up here.
Professor, I have a small question regarding the exam.
Yes.
So in the written portion, I did really, really, really good. Like I explained the things really well, according for me at least. Is there a way for me to copy my answers and put them in another test so I can just retake the multiple choice and the true or false?
I am not sure about that. But there's a possibility that your problems will be different anyways. So I suppose you can copy it, but then like I said, when you retake the test, it might not give you the same problem. So how to copy that, I'm not sure. I don't know if I disabled copying.
Yeah, it is disabled.
Disabled screenshot.
Yeah, I think it's possible. Yeah, screenshot is possible because I did good, but I did really stupid mistakes in the true false and the multiple choice. Like I could have easily avoided it.
Yeah, so my suggestion would be screenshotting it. And I'll try to remember to disable or not to disable the copying for next time, because I think I might have disabled the clipboard.
Yeah. Professor, small question.
Yeah.
What?
Excuse me for my tardiness yesterday. I was not able to attend the class.
No, you must ask it. What's the title?
Did I miss anything like major?
We recorded it, right? I think we recorded it.
Grow mindset or
It
something?
was recorded. It requires a password, but I
Well,
think the
mindset.
password is included in the inbox link, I guess.
Grow mindset.
I know.
So if you go to the Zoom page in Canvas,
Mine scrolls my side.
and then cloud recordings. Do you guys get cloud recordings or just previous
No,
recordings?
okay.
Okay.
And then if you click on, yesterday was Monday, right?
Yes.
If you click on that, you'll see the invitation. I think you should see the password there as well. So I'll post it in the chat. Password from yesterday's Zoom recording. Oops, I forgot to put the password. There it goes.
So the passwords are not required to view the recordings, right?
I'm not sure.
It's going to be
Eight.
required for Monday's video. Because
Yeah.
I tried to watch it last night and it wouldn't let me.
So
Okay,
at least
perfect.
for Monday's video, and I don't know how it's going to go for the rest of the time, because they started to do the restrictions, I guess, after a lot of reports on Zoom bombing, and so we had to update. I had to update my Zoom app, and then I think it's automatically gonna have restrictions, and I don't know if those passwords are permanent or automatic or whatever. So let's start with a picture.
Professor,
Yeah,
I just have a quick question on the theoretical exam.
yes.
So I took a first attempt at it and realized that I need to like study way more than I thought I have to.
Okay.
But what I'm kind of worried about is the second time I take it, will the questions be completely different? Should I be prepared for that?
I don't know if they're going to be different enough. It's not just the number change, but the pictures might look the same, but the numbers will change probably. And so,
So is it still the same types of problems?
yes. So I just uploaded this. I will post it after class today, and some people got it in the chat. I'll send it. Let me send it again because I think it's easy enough to send real quick. So there's an outline for the chat or for the test. There's the proctored portion. FR means free response. I'll just put that FR equals free response. So there's going to be free responses. The first 4 problems and number 13, 12 and 13 are free response problems. And then the rest are all revolving around this idea that, so number 5 is going to be identifying level surfaces. And then number 6 is the chain rule formulas. And so those formulas that you'll see in the chain rule, the one that you did in your first attempt will probably be slightly different in the next attempt. So in other words, I might change the problem, but the choices might still be the same. But then the actual correct answer might be different from the first problem.
Okay.
Or the choices will be different, but then there's a slight change in the language in the problem itself that would make you choose a different answer. So something like that.
Also, in the off chance that it does give you the same question, the answers are often in a different order than what they were in the previous time. So don't click the same spot, read the answer.
Yeah, so make sure you read the answer carefully. So my idea was to go over, what did you say? The local extrema questions. And so by that, I was going to look at, this is, I think this is the wrong section. It's 4.6. Gradients. Okay, so we need to go to 4.7.
Is today's like supposed to be a review or something?
Yeah, we're just reviewing. I don't have anything set that I had made aside from the outline probably. There's nothing else really that I was going to plan to do.
Mm-hmm.
Today and tomorrow are optional, like office hour study classes, because with the days he was going to give us the test.
Okay, yeah. Okay.
You don't have that many people here, huh? Okay.
Yeah, that's why I was like, there are only 8 participants. What am I doing? And I'd finished the test, so I was like, I did not know because yesterday I did not attend the class.
Yeah. So what I'm worried about is some of those people that have not been in our classes. Sample local extrema problems. So let's take a look at a problem that's might be similar to a problem that's, I don't think I graphed anything this fancy, but there's things that I want you to get from level curves. And here's an example of a level curve where they have labels. And so the labels here tell you the height of the curve at whatever points there are. And so what I want you to do is be able to identify like the maximum, the minimums and stuff like that. So I want to, first of all, take a look at the places where they have these X's. So your level curves kind of look like this, right? There are these points that I kind of labeled. What is happening in those places? Any ideas? Saddle. So those will get you your saddle points. Now, there are these other places. I'll do this in a different color. There are these other places that are circles, right? They end up being circles. And so those are going to be your maximums or minimums. We want to be precise. They're more like local max or mins. And what you have to do to decide whether it's a maximum or a minimum is to look at the level that they're at and the level around it. So these are kind of circles, but they're kind of concentric, right? And if you imagine a three-dimensional surface getting cut horizontally, you'll see that if they're going to be a maximum or a minimum, they're going to end up being circular or something like that. Now, if you look at the numbers around it, so if the numbers outside, this is negative 2.5, and then as you get closer and closer to the middle, it gets negative 2.7 and then negative 2.9. What do you think is happening to this one particular critical point?
Based on the curve around it, I would think it would probably be -3 at that point.
It would be -3, but more precisely, what is it? Is it a local max or a local min?
Local minimum.
Local minimum, because you got -2.5, and you go inside more, you're going to get 2.7, and then inside more, you get 2.9. So it will probably drop down to -3, but more importantly, it'll end up being a minimum because you keep going down, right? Now, let's take a look at this other one. So if we take a look at this one, this critical point here, again, it's circular, so we should look at it as a maximum or a minimum. And if you look at the concentric circles around it, there's 1.5, 1.7, 1.9. It's probably going to be 2, probably. But more importantly, max or min?
Local maximum?
This would be a local max, right? Because the concentric circles around there leading up to the middle goes higher and higher. Okay, so does that make sense?
That helps a lot.
So one of the questions is focused on that. Say it again.
I had a hiccup on one of the saddle point questions. I'm just like, or I don't remember if it was saddle point or not, but I'm just looking at it, I'm like, oh, I don't remember how to describe this.
Yeah, so that's going to be your key. Saddle points are going to be X's, and then circles are going to be max or mins, and then anything else on the sides here, they're not contributing anything. It's not going to be a max or those are not critical points. Okay.
What about when finding maxes and mins using Lagrange multipliers?
Yeah, so let's take a look at Lagrange multipliers and see how their pictures look like. So Lagrange multipliers, and we're only going to look at Lagrange multipliers of 2 variables. Let me show you this picture first. The computer is running a little slow. So just to give you an idea of how Lagrange multipliers work, remember Lagrange multipliers is saying that your function f, the gradient of that function is actually going in the same direction or opposite, but there's parallel to the gradient of g. And so since they're parallel, and there's only 2 vectors that we're looking at, we're really just saying one of them is a scalar multiple of the other. So that's the whole idea behind Lagrange multipliers. Now, the other part is that the gradients are perpendicular to level curves. So if we take a look at f, the gradients at certain points, depending on, I think I actually drew, there's 2 possibilities here for the gradients. And I think I'm drawing the correct one. And by the correct one, I mean, which one's the correct one? This is the correct one, because it looks like it's pointing in the direction of fastest increase. And so this is 11, and the one before that was 10. So this is going to be going down, and this is going up. So I think this is the gradient. The gradient's pointing that way. But at this point, I'm not too concerned about which way it's pointing. I'm only concerned that it's perpendicular to a level curve. So the gradient that I'm looking at, if I look at 10, level curve 10, let's say my gradient is going this way, gradient of f. And then this also, we can take a look at the gradient of g, and this is the g curve, and so the gradient can be, you know, whatever you are, wherever you are at that point, is going to be pointing in a certain direction. But if I look at this point here, the gradient is going to be perpendicular to a level curve, and I'm randomly drawing it going in this direction. It could well have been going in the same direction as F, but it's parallel. So Lagrange multipliers, if you look at the level curves, these are the level curves. Level curves of the function f. And then this is actually one level curve of G, but it's actually the constraint, also constraint. And then by the constraint, it's like g of xy is equal to some constant. You can find the local max, or not the local, you can find the absolute maximum or minimum by looking at the place where they don't just intersect, but they look like they are tangent to each other. So the place here, place where they are tangent to each other would be the place where you can have the max or min. And looking at this, it looks like the g of x exists here at level 7, 8, 9, and then this is 10 at this point where they're tangent to each other. And if I keep going on that g curve, it's going to go back down in level. So in this case, it must be a maximum. So in this problem, max, draw another line here, graph. Max is attained at whatever point this is. I don't know what point it is. Max is attained at the actual level or the actual height or the actual value is going to be 10 because that's where it happens. So if we try to translate that, let me see if I can find another problem similar to that in the book.
Professor?
Yeah.
The password did not actually work for the Zoom conference.
From yesterday's meeting?
Yes.
Oh. Five 83900.
Yes, it did not work.
April 13th. That was yesterday, right?
Yes.
Did they ask for a password?
Yes, it did.
583900. Did you try it, Stephanie, when I gave you the password?
No, I didn't try it.
Don't know what to do about this. Why don't I try something else?
So it's gonna be 583900.
Yeah.
Yeah, no. I don't want to interrupt your
No, it's okay. Here, let's try something else. Are you on chat still?
Oh yeah, I am.
All right, let's try get that link in the chat. See if that'll. And if it doesn't, I'll find a way to post it up. Today
it also required a password. Yeah.
Are you going through Canvas?
Oh yes, through my Canvas. Yep. Five, 3, 9, 0, 0. Not a robot.
Can you guys, if you guys are available, or can we try it? Because if it doesn't work for 4 people, then it doesn't work.
So I've tried it from both the Zoom button on the classroom as well as it'll send you an email in your inbox for Canvas with the recording link. I've tried both the link and from the Zoom, and yeah, I couldn't view it.
Okay, that sucks. So we're going to have to, I'm going to have to download it and
Can't you
upload
just
it.
use the password, or just we're forced to have it?
I don't know. Let me get this here first.
We didn't get Zoom bombed yet.
No,
Yet.
we haven't gotten Zoom bombed. All right, so I downloaded it, but I'm gonna upload it later on. And so it's requiring a password, and the password is not working. Is that correct? Is that
Yes.
accurate?
Yep. 583-9900.
583-900. So cloud recording. ID number, chat file, and if I share this cloud recording. Yeah, I don't have I can't see a way to cut the password out. All right, so if you guys mess around with that during this time and are able to get it to work, then let me know, and then we'll figure out what's going on. If not, then I will upload yesterday's and today's onto YouTube, and I'll have a link.
Okay, yeah, that would be awesome.
Yeah. All right, let's get back to the example that I was trying to dig up. I was trying to dig up an example, and here's one.
Sorry for interrupting.
Ah, my computer is so slow. I usually restart my computer, and I didn't get a chance to. All right. Oh, there's no levels. I don't remember if mine had levels. I think mine had levels. Let me just take a look at the actual problem again. Oh, so they have a level. Okay. All right, so this is a setup. Your actual function, f of xy, is x squared plus 2y squared. And so this 2 here just says that this has level 2. That's not a negative 2. That's a k equal to 2. And so this is a paraboloid that's going up. So this must be k is equal to 0 here if we want to label it. And maybe k is equal to 1. I guess this would be 1/3, no, 2. I don't know, 4/3, 2/3. And this is k is equal to 4/3. And this is k is equal to 6/3, which is 2. Maybe. Okay.
I think
So these are the levels. I just labeled the levels using these things. And this other one here is your G.
that place where you write k equal to 4/3, that is k equal to 1.
K equal to 1.
Yeah, they label it there. Down there.
Oh, yes. Oh, then this is all wrong. Erase. Thank you for catching that. Let us put k is equal to 1 here, because they actually did label it, huh? So k is equal to 0 is here, which is not going to matter. It's not touching anything. G of x x squared plus y squared is equal to 1. So that's just the unit circle. Oops. So this circle, the circle in the blue is x squared plus y squared. And then we're looking at only one level for that. So that's is equal to 1. So this is your constraint. So this is your actual function. And then these things here are levels. Now they put the levels in black and in red, but the two levels that are actually stated in red are these ones, because they are the places where the graph, the constraint and the level curves are actually tangent to each other, which means they have the same, or not the same gradient, but the gradient is pointing in the same direction. And so what you have to ask yourself is, what level are we? How high is this in terms of the graph? So this here is at level 1. So this is like your z is equal to 1. And then your x and y is whatever x and y is. And you should be able to read that on the xy plane. So I know that the y is equal to 0 and the x is probably equal to 1. So this is a point, and this is going to be either a maximum or a minimum depending on where the other points are. So if I move out of that, I'm going from a level 1 to a level 2. So anything outside of this must go higher. So this must be a minimum. And it's not a local minimum, it's an absolute minimum based on where it is, based on the constraint. Now, let me look at this point here. And this point is tangent, so it must be an absolute max or min again. And I can identify that the curve that it belongs to is 2. So that's my z value, right? Because f of xy is equal to z, and z is equal to 2 at that level. And then now I can figure out that this point is, the x is 0 and the y is -1. And then I can further say that since if I go out of that curve away from that tangent, my level is going to go from 2 going towards 1, so it's going to go down. So this must be up high. This is an absolute maximum. And then there's two more points. And then, you know, depending on what level, you'll find that they're absolute max and absolute min. I'm not having feedback. I'm getting anxiety. Yeah, so the WebAssign, when you do the WebAssign, you have to submit everything. Sorry about that. Okay, so let me see if they have a three-dimensional picture of this. This is the three-dimensional picture of that. And I'll try to squeeze it in here in our notes. Just down here in the bottom. So you can barely see it, but the curve, the red curve, the red curve is being projected from the XY plane up to the surface. And then it goes down like this. And we can see from that red curve that we're gonna have our minimum happen here and our maximum happen here. And then there's a couple of other places where it's gonna happen around that, but there's two of them here at least. And you can see the two of them at those places. And so the key here is that the level curve and the constraint are going to be tangent to each other. Those are going to be the important points. And then you need to look at the levels to see how high that level is to determine whether it's an absolute maximum or an absolute minimum. Okay? So there's going to be a couple of questions that are focused on that, or maybe just one. Is that cool? All right.
So it is the absolute minimum and maximum for the level curve, not the constraint.
It's the absolute maximum and minimum of the function. So let's say this right. It's the absolute max and minimum for the function given this constraint. So the function itself is this paraboloid. And what we're saying is that, what if I don't look at all the, because, you know, the paraboloid keeps going up. And then also there's a minimum here, absolute minimum for the paraboloid itself. But I'm saying I don't care about the rest of the paraboloid. All I care about is what is happening just within this constraint, just within the circle. Circle on the XY plane, but then it gets projected on the surface, and then it goes up and down along the surface. And so I'm looking for the absolute max and min of the function given the constraint. And so I'm only constraining myself to that one curve. In this case, it's a circle. And then I'm trying to find the maximums and minimums there. Okay?
All right.
Cool. All right, so those, the second derivative test, I think those are just second derivative test questions. The local extrema question is it's the level curve, looking at the level curve. And the Lagrange multiplier is also looking at the level curve. I think the partial derivative and directional derivatives are also looking at level curves. So let's take a look at one of those problems. So Lagrange. And I think I was meaning to ask you more kind of deeper questions about the gradients here, but I ended up not doing it. So let's see if we could just take a look at a level curve. Any random level curve would do. I think we had some good ones in in the second derivative test section. Let's take a look at this one. So the important part about reading a level curve is knowing where you are and which way to go to find the maximum and minimum. So let's put ourselves somewhere here. Let's put ourselves here. So let's say the point equals 1, 0. So what I want to do is I want to figure out a couple of things maybe. If this is my function, f of x, y, I want to know what f of 1, 0, not f, but the derivative, the partial derivative with respect to x at this point 1, 0. So what you have to do is that you're assuming that your direction x is actually in the I direction, which is the vector 1, 0. So that's like a directional derivative question, but it's really just a partial derivative. So it's going in this direction. That's the I direction. And so you have to ask yourself, if you go in this direction, you're going to go from a level 5 to a level 6, right? So what can you say about f of x, f sub x at 1, 0?
It's positive.
It's positive, right? You can try to estimate also, because this thing is going to go, this is 1 whole unit. So 1 whole unit I should have drawn my vector a little bit longer. But if I go take a step, maybe this is about a quarter or maybe a third. So this would be like the difference in the z's goes from 5 to 6. And then this is only 1/4 about. So the difference, if I go take a step in the z, the change in z over the change in x. So this is going to be 6 minus 5 over 1/4. Just the distance of 1/4. So that you can actually approximate this to be 1 divided by 1/4. So about, this is approximately equal to 4. I'm not going to ask you this on the test, but that's one way you can approximate. Not only is it positive, but you can actually get a value, and the value is probably going to be 4. So that looks like it's pretty steep. Now, going in the same point, from the same point, what if you go in the j direction? This is your j vector. So what you're actually asking yourself now is, you're looking at the derivative with respect to y, right? So the j direction is the y direction. And then I'm more concerned about this, not defining the exact value, but determining whether this is positive or negative, or maybe equal to 0. So I'm going from a level of 5, and my next level that I hit is 4.2, and then I hit 4, and then eventually get to 3.2 and stuff like that. So what can you say about this f sub y?
Less than 0.
Less than 0. It's going to go 5, 4, 3. It's going to be decreasing. It's going to go down. So it's going to be less than 0. So let's make a note here. Levels are decreasing. So back in Calc 1, if something's increasing, the derivative is positive. It's decreasing, the derivative is negative. So in this direction, it's decreasing, so it's negative. In this direction, it's increasing, So let's make a note here, levels are increasing. So that gives a positive direction. Okay. Now, if I was sitting just here, if this is my new point, let's call this point Q. At that point right there, what do you think is happening with the derivatives there? Fx at Q or Fy at Q? What do you think is happening there? So I'm looking at Q now as a different point. I'm not looking at 1, 0 now, P. I'm looking at Q here. I think that's 1, 1. What do you think the derivatives are at those points? What do you think the derivatives are at that point?
That's
Negative.
But Stephanie, what'd you say?
That's a local maximum, so they'd have the derivatives would have to be less than 0.
No, it would be exactly 0 because it's a local maximum, right? If it's a local maximum, remember the maximum, if you attain a maximum, your derivative is 0. So I know that if you take a step, it looks like you're eventually going to be going down. But what we have to see is, I'm looking for a bowl here, but what you have to see is that this thing is happening at a maximum point, or if it was happening at a minimum point, that would be the same. So these would both have to be actually equal to 0, and they would actually be critical points. So since Q is a local max, in this case, it's a maximum. I think it's a minimum. So it goes from 3.7 to 3.2. So this is probably going to be lower, right? So this is a local minimum. Since Q is a local minimum, partials, I was going to first order partials, partial derivatives are 0. Okay, so if you're sitting at a maximum or a minimum, then it's going to be 0. And you know that you're going to be sitting at a maximum or a minimum if you have concentric circles around it. Circles, ellipses, whatever, that kind of enclose it. Okay. So we could do one more here. And for this one, I want to look at the 0, 0 point. This point here, PQ, let's call this point R. That's 0, 0. Actually, no, that's not a good thing to do. I'm not going to ask you questions about this anyways. I was going to say it's tangent and it's also perpendicular, but it's a saddle point. And so I think your derivatives are going to be 0 again because they're going to be critical points. So why don't we just say that? So R is a saddle point, also a critical point. So Fx at the point R is equal to 0, and Fy at the point R is also equal to 0. So critical points happen at the local max, local min, and saddle points. And if you're looking at those saddle points and you're trying to estimate the partial derivatives, then they're going to be 0 because they're critical points. Okay, is that cool?
Yeah.
I think that gives us good ideas for some of these problems here. The 6, 7, 8, 9, 10 questions.
I feel like if I take the quiz again after we get off this call, I'm likely to do better than I was if I hadn't come.
Okay, that sounds that sounds good. And this is recorded, so hopefully people will access it and take a look at it. Maybe before or maybe after their first attempt. Yeah. Anybody else have any other questions? Something just happened. Am I still sharing my screen?
I can still see your screen.
Okay. My view of you guys, I have multiple screens, and so I was looking at the view, but now I can't view everybody. Oh, maybe because there's only 4 people now. Maybe that's what happens. Take exam and have some questions. Okay, you want to ask questions? Go ahead and ask questions, and I'll try to answer it, and everybody can benefit by listening too.
Okay, I had a question on, well, I took a video, I didn't take pictures, so that'll be hard to show you.
Yeah.
But let me find it. There's one, when using Lagrange multipliers to find the extreme values of f of x equals xy, subject to the constraint, and then you give a function, we can examine the level curves of f of x and the graph of the constraint g of xy equals 0.
Yeah.
And so I got my 2 critical points, and I said that, so I chose 2 maximum and 2 minimum, and the correct answer was 1 maximum and 1 minimum, and I'm just confused about it, but I don't know how to show you the problem. I tried sending you the video and I couldn't.
So if you think the answer was not, if you think the solution was not correct, then I'll take a look at that. I did explain it here. If you're, I'm worried now. In this particular scenario, in this particular example that we have, that we kind of worked on, we had 2 maximums and 2 minimums. I only mentioned 1 here, but there's 2 maximums and 2 minimums. And so it's quite possible that I might have selected the wrong answer, in which case I need to take a look at it again and make sure it's correct. But the idea is to look at the places where they look like they're tangent to each other, and then look at the level that they're at. And so the higher level, of course, would be the maximum, and the lower level would be the minimum.
Yeah, that's what I did. So because you can select multiple answers.
Right.
So I selected 4 and I just got 2 out of 4. So.
Okay. So you only took it 1 time so far?
Yes.
All right. So let me take a look at that when we get off, and then I'll send you an email to let you know what I think, and if you were actually correct, then I'll let you know. And if I was correct and you had and you had some logic thing, then maybe I'll send you an email about that too.
Okay.
I had a trouble with what I think is the same problem that she described. It was the graph is mirrored about the origin, I think, and so I picked 4 local max, 2 local max and 2 local min, and it was wrong.
Give you the wrong answer. Okay.
So I have been wrong, but if I was, I don't understand why.
Yeah, so that's what I'm worried about, because I think if I remember correctly, the pictures that I selected were like ellipses and circles and things like that. And so I'll need to take a look at that and see. Although the levels might be, there's this one graph that I was working on. Let me plot it with CalcPlot 3D. Just X times Y. And if I were to plot this using level curves, wait, that doesn't look, it's X to the Y, X times Y. There you go. And then I'll plot this using level curves. Just taking a look at some level curves, create plot. So one thing I want to show you, just to make sure that I'll check my answer also, but just to make sure that you're checking your answers.
Oh, I think I know what the problem was. The blue circle, the way it overlaps the values, you can't tell if there's a negative or a positive there.
Yeah. So yeah, so these are negative values. These are also negative. So these are positive. Positive. So given that, if you're whatever shape, whatever your constraint is, if your constraint is like that, then we're looking at positive on this side. So this is the maximum values. And then this would be a minimum here. So the place where the maximum and min happen dependent on whether they're positive or negative, the height of the levels. So that might be the issue that you guys might be having. I'm hoping. If I'm correct, then that's the issue. If you guys are correct and I'm wrong, then I have to change the problem or give you credit for it appropriately, which is possible. Okay.
Yeah.
So you did. I hope that makes sense. And if you take a look at that problem again, see if this is the scenario that's happening.
It is, but they had two negative twos and two positives, like just the graph you showing us, and the blue circle going through those. And
Yeah.
it shows that the two positive twos were the maximums and the two negatives were the minimum, because they happen at different points.
Yeah. Okay.
Oh.
So again, I'll take a look at that. I'll take a look at the actual problem, and I'll take a look at your test and see if I need to, adjust the grading for that.
Okay.
Okay.
Yeah.
Cool. Anything else?
There was another question on the test. There was this graph that we had to find the region, and it's the function. It's going from y equals the square root of x, y equals 0, x equals 1. And so I chose that so if it goes through y first, it's going to be from 0 to 1. I mean, from 0 to the root of x.
Mm-hmm.
And for the x component, it's going to be from 0 to 1. But it said that it was wrong.
Might there be another choice?
Yeah.
I think you might need to select the other choices that would make sense also. Because this region here, we can do this with going through the x first, so there'd be dx dy.
Mm-hmm.
But we could also do it dy dx. So there might be another option that would also work.
It is, but it didn't let me select multiple answers. So that's why I chose that one, because I knew it was correct, but the other one was too. So I was like, okay, either one will work, and they graded mine incorrect. But I feel like
Okay.
it's correct, right?
Yeah, well, it seems like it should be. If
Because
if in fact it was correct.
right, because if it's going through y, it's going to be 0 to root x.
Mm-hmm.
So the function is y equals x squared.
Okay.
So
So
I mean,
I'll make a note of that. I'll make notes for myself. Did you have any of those issues too, Stephanie? I guess I'll check both of your tests that you took so far today.
I'm having a hard time remembering everything I had trouble with,
Yeah.
but when she started talking about that graph, I remember, oh yeah, I remember having trouble with that graph.
Okay. All right. So why don't I take a look at that, and I'll send you an email, and Stephanie, I'll check yours too. So I'll check your test. I won't be able to do it right away, but I'll probably be able to get it done in like an hour or two, and I'll send you guys an email to let you know I checked it off, and then I'll talk about the issue problems where there were issues, and then I'll say whether I was wrong or whether you were wrong or whatever, and then you guys can hopefully from there be able to take the test again.
Thank you.
thank you.
Okay.
By the way, the quiz had a lot of mistakes too that I feel like they're mistakes from you, I believe, because I don't know if you were just given the graphs as an example, and we had to do the integration according to what you were doing with the fruits, or both of them were the same, because
It's supposed to be the same.
oh, because you were talking about the fruits, and then you changed the theta, or like I don't what was the other one? Functions. Before you said like 1/2 y equals 1/2 x, and then you said y equals x squared. So I was just confused.
Okay, so I know there's one problem in particular where on the paper where I have it in front of me, the equation was wrong. And then David emailed me actually and told me about two particular problems. I think it was number 8 and number 10, where the graphs were not the same. I think that's what you're talking about. And I haven't taken a look at it in a while, so I'll take a look at that as well. Then, I'll probably give everybody, just the points for those problems. And they're all free response anyway, so I'll have to check all of them. So there's some where there were no issues, and then so for those I'll grade regularly, but then those places where there are issues, and as far as I can remember right now, it's number 8 and number 10. I'll make sure that people are going to get credit for it.
Okay.
So I'll put that in my notes. I'm taking notes here on the side. Check.
Because the ones I found issues on, it was number 4 and number 7 as well.
Okay, so problem number 4 and number 7. This is quiz number 8, right?
Mm-hmm.
Okay.
I think
So I'll take a close look at that, and then I think David was talking about number 8 and number 10, so I'll check all those.
okay.
I'm glad I'm not the only one who noticed a problem with number 8.
Yeah. So I kind of put this together kind of quickly, and like I said, I do this in person. When I do it in person, it's I get to ask you guys if you're understanding what the scenario is. Here I'm kind of putting it together. I don't have anybody to check it before I deliver it. So yeah, I'm sorry for these little errors that come up, but I'll fix it.
Okay.
Thank
All right.
you.
So we good for now?
Yeah, I'm good.
Okay. So in a couple of hours, I'll hopefully get your test taken a look at, And then once you got the problems all sorted out, you can try it again later on tonight.
Okay.
All right.
Mhm.
Cool. So that's it for today. We'll sign out, and then we'll see how the recording goes.
All right. I might show up tomorrow again for more study help.
Sure, sure. No problem.
Bye.
Okay, bye.
Bye.